All right, continuing on in section 1 of chapter 9 here, we're going to finish up this section by talking about the tornado. Common in the Midwest, well, more common in the Midwest of the United States than anywhere else. We can see variations on the idea of a tornado, usually much weaker tornadoes in other areas. Less common in Europe. I have heard of tornadoes touching down in Great Britain, even though it was a fairly weak one as tornadoes go. It still made huge news. There's been tornadoes in Milwaukee, Oregon. I've heard about them off the coast of Oregon. Again, usually much weaker than the Midwestern ones. We still don't know everything that goes into the creation and functioning of a tornado, although we're learning more all the time. When I was younger, basically the section on tornadoes was pretty much, here's the description of a tornado, here's the damage a tornado can do, that's pretty much all we know. Now we actually have some ways of describing the formation of tornadoes, and like I said, we're still learning about them. Discovery Channel has had many shows about tornadoes and pretty much about the people trying to study them. But a tornado is a narrow funnel of powerful, rapidly whirling wind stretches from the cloud to the ground. It's usually not officially a tornado until it touches the ground. Tornado formation. Like I said, this is fairly new information within the last few years here. It's thought that there are two mechanisms for tornado formation. The first one our book doesn't actually give a name to, but it gives a description. Involves interactions between a thunderstorm's downdraft and an updraft forming a cumulus cloud in front of the downdraft. This is thought to form the smaller types of tornadoes that we might see in other places other than the Midwest. And then there's the second mechanism, which forms what's called a mesocyclone. I just gave it the name here, the second mechanism, the mesocyclone. Begins when differences in wind direction and speed at different altitudes cause a horizontal cylinder of air to rotate. So along the ground, really, and it's horizontal. An updraft picks up the rotating cylinder, causing the cylinder and the updraft to merge, and then spiraling up and creating what we know as a tornado. This is how it is. This is the way it's thought that the most powerful tornadoes form from the rotating updrafts found in many supercell thunderstorms. Remember we talked about the thunderstorms and how those can have those strong updrafts. This is how it's thought that they blend together with these tornadoes. And here we have a diagram of a mesocyclone forming. On the top left, we have strong winds up top, weaker winds on the bottom, creating this rotating band. But it's a horizontal column, meaning it's laying down. We get this circle that's at the top, rolling down to the ground, up again, rolling down to the ground. And then a thunderstorm starts forming. And this updraft picks up this horizontal spinning wind there. And after a while, they merge, and we get this mesocyclone going really from the ground to the upper part of the cloud there in the big diagram. It says mesocyclone 3 to 10 kilometers in diameter. It's still that anvil-shaped cumulonimbus cloud. And here at the bottom, you can see that a tornado might form as the clouds reach down to the ground there. So that's a diagram for the formation of a mesocyclone. And then we have the condensation funnel. When I said the word tornado, this is probably what you thought of. The air the tornado pulls upward reaches the dew point. It condenses. This is the most distinctive visual feature of a tornado, that swirling cloud with maybe dirt and other debris in it as well, reaching up into the cloud. So the condensation funnel is the most visible part. The scale used to measure tornado strength is the enhanced Fujita scale. It used to just be called the Fujita scale. However, new data caused them to revise the scale, and it was then dubbed the enhanced Fujita scale. In some of the older movies, you may hear referred to an F5 or an F3. That's based off of the Fujita scale, the original one. Now, they might still actually use the term F or EF because they did rename the scale. I've heard of waterspouts forming off the coast of Oregon and Washington before. Basically, it's a tornado that forms over water, not necessarily as strong as some other tornadoes. These can be pretty weak. And they're called water spouts because they're basically just picking up water and it goes into the cloud. They're not necessarily dangerous unless they get over land or if they hit a boat, I suppose. Another one, they're not actually the same as tornadoes, but there are some similar features, and that is the dust devil. Really, the only similar feature is that it's whirling air, vertical whirling air, because it's not associated with a cloud at all. You can have dust devils on a clear day. Dust devils usually are not dangerous. I've heard of some pretty strong dust devils, but really that's just going to whip around leaves and dirt and stuff. They're called dust devils because they generally form in drier areas, and they pick up a lot of dust. I was doing training in Fort Yakima once, and got hit by a dust devil. I mean, me personally got hit by a dust devil. That was an odd sensation, but it was by no means life-threatening at all. It was just weird. So, yeah, the dust devil there. And go ahead and answer the science video question for 9.1b. And we will continue talking about this in class in the near to immediate future.